So it's 10 o'clock. Good morning, everybody. Welcome to the second day of the Netnod meeting. Just quick show of hands. Who was at the social last night? Okay. Who had the burgers? Who had the fish? Consensus for the burgers there. Good. Well, we have one session of presentations today, and so we'll crack straight into it. The first speaker will be Ondřej Surý. I hope I haven't mangled your name too much. He's from ISC, he's Director of DNS Engineering, heavily involved in the DNS and the internet community. So please welcome Ondřej to the stage. Thanks.
Hi, I'm Ondřej, and now I work for ISC for a year and a half, trying to make Bind better. So quick show of hands, who uses Bind here? And who loves Bind? Who hates Bind? And who has love-hate relationship? Okay, so, when I joined ISC, I thought this is like a good opportunity to work on something really, really old, because, you know, Bind was first released in the year 2000. It was written from scratch. It used something called design by contract, which basically means that instead of having a buffer override that would like lead to execution of the code on the stack, it crashes. So, you know, pick your poison. But you know, I think that the decision was good to make Bind crash rather to have yet another remote vulnerability. It was also the first DNSSEC implementation in a DNS server. By the time Bind 9 was designed with DNSSEC in mind. Of course, it was the DNSSEC before the current DNSSEC, so it had to be rewritten anyway. So let's move to more current time. So Bind 9.11 ESV, the ESV means Extended Support Version, which basically means if the release is marked as ESV, it will be supported for at least 4 years. You know, for people who don't like to upgrade working stuff. It was also the first Bind release under Mozilla public license. ISC changed license from the ISC license, which was very permissive, to a Mozilla public license, which is per file based. And it featured stuff like to ease management of zones, like catalog zones. You can now add zone, deal zone with RNDC command. It has a DNSSEC key manager, which helps with rotating the keys. It added support for negative trust anchors if, you know, somebody forgets to reassign the zone, so it doesn't stop working. That's important for operators of the resolvers. It supports DNS tab for, you know, tapping on what's going on the wire, DNS cookies, which is an important mechanism against DDoS attacks, and you know, if you want to make your traffic smaller, you can enable minimal responses to any queries. So, so that was in 2016. Last year, in the I think February, we released Bind 9.12 that also had new features, NSEC aggressive use. What it means is that if the zone is signed, DNSSEC signed, and you receive a response that the domain doesn't exist, it can use the whole range which NSEC covers to answer from a cache. So it reduces the number of the queries that goes to the upstream servers. As a reaction to recent attacks on DNS, there's a support for self-stale, which basically what it does is when the upstream servers are unreachable and you still have the entry in the cache, you stretch a TTL a little bit until the servers are reachable again. So that helps if the you know the provider is under attack and all the servers are unreachable. So it helps with users to get the correct answer. Then one of the major things that has been done. There has been major refactoring in the query find, the most important function to that was really, really long, so it was split into small pieces. And there's a good presentation on that from 2 years ago by Evan Hunt, my colleague at the DNS.org. And there was also a speed-up factor, which was quite significant in some scenarios. And again, some DNSSEC improvements, new algorithm support, and it was obsoleted by Bind 9.14, so it will now only receive the security updates for a couple of months, and then you should upgrade to, if you are using Bind 9.12 to Bind 9.14, which was released like 2 weeks ago. You know, it's still a baby. It goes under a new release schedule. We prepared, I will tell you about that more later. Again, we did a lot of refactoring and modernization of the code, and also added the new features. It features the QNAME minimization. I'll tell you what it is later, and mirror zones, and we now can have plugins, like internal and external plugins that can like modify the query response processing. So, well, for the modernization part, well, I told you already that Bind comes from year 2000, where there were a lot more diversity in the Unix and Unix-like systems, which doesn't exist anymore. So we removed a lot of like workarounds for all the broken systems. So if you are hiding that SGI under your desk and you still think that it could run modern Bind and modern DNS, then at least upgrade your compiler to support C99. Bind now also requires POSIX threads, advanced socket IPI for IPv6, and standard atomics, but we do have some workarounds, so it works even with the older GCC that has built-in atomics. So that would be GCC 4.8. So if you can upgrade at least to GCC 4.8, it will still work. But yeah, we dropped support for a lot of old systems that doesn't exist anymore, and that's the reason is because we don't have those systems. We are not able to provide any assurance that it works at all. So and it's actually better to just upgrade hardware. The other thing we did for the release was the crypto refactoring, the PKCS11, which is the interface to communicate to hardware, the HSMs, so the hardware box that keeps your key secret. So the PKCS11 was used, or was intended to be used for all cryptographic operations, even though many of the HSMs and the libraries didn't support the algorithm. So there was, again, a lot of workarounds and testing, and you have to compile Bind for a specific HSM. So that's mostly solved now, because the PKCS11 is now only used for public key cryptography, which means to keep your DNS keys secure, but all other operations are like random number generation and hashing and HMAC for TSIG is now performed by OpenSSL, so which means OpenSSL is now mandatory. We also did some performance improvements, which allowed us to increase the performance by 100K or more. Again, it depends on the scenario, and that's because of the refactoring we did. So the task manager, that you receive a packet from a network, and before there was just one thread that just handled all the connections and it just like multiplexed it to other threads. So that's now, it runs multiple threads. So when you are listening on the interface, it can process the packets more faster, and it allowed us like, this is the Bind. Sorry, this is Bind 9.11, this is 9.12, and the last is 9.14. It was somewhere in the picture, but it disappeared. I'm sorry for that. But it goes right and up, so it must be good graph. QNAME minimization. Who does know what QNAME minimization is? Okay, a couple of hands. So it's an internet standard. It improves DNS privacy. So the information in DNS aren't really private, right? Because you can query them from outside. But it doesn't mean that the transactions doesn't have to be private. So the change to the resolving, and I'll show you this in more detail, is that the resolver now sends only minimal info it needs to each authoritative server, so it doesn't leak the information that much. And it has been enabled by default in relax mode in bind 9.14. The relax, there are like 3 options: off, relax, and strict. So in relaxed mode, if something like bad happens on a wire, it falls back to the old mechanism and tries to give you the answer. So the normal DNS traffic goes like, here you have stub resolver, here you have the resolver, which would be bind in this case. And if you ask for www.isc.org, it will go to the root zone system and ask for www.isc.org quad A, and it goes at every level, and it leaks the whole information about the query, the original query. So that's how it works right now. So the QNAME minimization changes that in a way that if the stub resolver, it means your computer, ask for www.isc.org, it goes to the resolver, and the resolver just leaks the, sends the minimum query. So it asks, what are the name servers for .org? And the root system answers that, and then it goes, it adds a level, and it asks, what are the name servers for isc.org? And it asks the org name server. And only then, finally, it goes and asks www.isc.org to the isc.org servers. So that at every level, only the minimum possible information is sent to the upstream authoritative server. So it doesn't leak so much information. So it is a protection against all kind of like passive listeners on the wire. Of course, it doesn't really help if you have somebody listening right just behind your resolver here. So, but if you like, if people are collecting data on the root servers, org servers, it helps with that because it leaks less information. So, root zone local copy, that's another feature I did in bind 9.14. This was work funded by ICANN, and there's again RFC, so it's internet standard. And what it is meant for, it reduces the traffic to the root zone system. So the configuration in bind and any other resolver that has the support for this, which might be like the implementations might differ, but basically what it does, it transfers the root zone locally inside the bind, and then it DNSSEC validates it if like it wasn't mangled in transport and it's still valid. And the root zone is only used internally. You can't query it directly. It will always go through the resolver. But it will be used locally for some time, then it will be retried. The bind will retry to download it again, and the cycle goes on and on. But basically, this reduces all the traffic that would go to the root zone to just one transfer per 12 hours, because that's basically how the root zone is updated. So this is improvement for the resiliency and stability of the internet. So that's the bind 9.14. So what are our plans for 9.15? I'm sorry, this is stock image from Keynote. I'm sure you know it if you have Mac. Somehow I forgot to change it, but it fits quite well. We love our bind. So there are 4 areas we want to focus, and that's performance again, because as you might know, bind is kind of underdog right now compared to other DNS servers, and we want to like put it back into the first league, so you don't have to worry about the performance. The other areas is management, then security and privacy, and like helping with the operations. So performance. Basically, the goal is not to be first, like have the highest number of the queries per second. from some point, it doesn't matter. Would you really care if the performance would be 1.5 million or 1,600,000? I don't think so. So when you get to a point that the performance is enough, I think you can stop optimizing, because bind has other advantages, because it's much more flexible but we are not there. And we want to get there. So you don't have to care about the performance of bind. So the big thing planned for this year is the whole networking stack will be rewritten and re-engineered, and changing the internals. So that's the thing that's not really visible on outside, because it's not a new feature. The goal is that the bind will perform familiar to you. So nothing will really change, but it will be simpler and it will be much faster. So it should improve both UDP and TCP in performance. And so far, the plan is to use a library called libuv, which is used in other projects. And it's a fully asynchronous library with the even loops. And it can use all the modern networking I/O that's available on the platform. So it basically shields the end application from the specific implementation specifics for the platform. So it can use ePOL, it can use KQ on FreeBSD, it can use IOCP on Windows. But for the application, the interface is still the same. So it helps simplify the code. It has asynchronous TCP and UDP sockets. And more stuff like thread pool, signal handling, high resolution clock. The library is really, really good, and I think it will help bind to be more simpler, because it won't have to care about all the stuff. So we would be able to focus on DNS again, not about it, like, will it work here? How fast it will work? Because that will be handled by libuv. So for the management, actually, this is an area where we would really like to get a feedback from you users, and that's the metrics and statistics we generate, because bind has a really too many counters, but we actually don't know what's useful, because we don't get much feedback on that. So if you are missing a counter, if you think there are too many counters, please tell us. So that's one of the areas we want to focus on this year, and change. Maybe remove some counters that doesn't make any sense, because they are used only internally. I don't know. There are counters for how the memory pools inside bind are used. I don't think that users care about that stuff. So we would like to hear from the users what's missing or what's extra and could be removed. The other stuff is the updated catalog zones. Because there's an update to RFC, and we need to align the two. If you don't know what the catalog zones is, which you might not, it's like meta zone that contains the other zone, so it's for easier provisioning. So if you have two binds talking to each other, you can have a catalog zone, and it will synchronize the list of the zones between the two. The other stuff, that basically the DNS over TLS, again, DNS privacy, so we don't leak metadata. You currently don't know what's in the letter, but it kind of leaks the metadata here. So DNS over TLS hides the DNS traffic into TLS transport. It's defined in these two RFCs. It's running on a different port 853. And this will be really the next transport we could add on top of the new networking code. So it will be also good for us, that we will know that if there's something like DNS over QUIC in the future, we'll be able to add it in a simple manner, instead of against hacking it together. So we will have something, the networking stack will be built on the libuv, and this will be a module into that will add another transport. So what needs to be added? Supporting clients, so you can debug it, because the dig and delve and the other tools that talks DNS are usually used to debug DNS, and so you need the support there. We should probably add it to named when acting as a forwarder, so it can talk to the upstream servers, to upstream forwarders with DNS over TLS, and also in server. So bind can act as a client and as a server. So the other thing that recently emerged from IETF is the DNS over HTTP, DOE. I have mixed feelings about this, because it mixes traffic with HTTPS. So it's much harder to control your networks, because then the browser can connect to big CDN and mix real HTTP traffic with the DNS traffic inside. And unless you are wiretapping the TLS, which is a bad thing on itself, you have no way how to control this, because it's hidden in the HTTPS traffic. That said, I strongly believe that we should not allow these big companies concentrate all the traffic to themselves. I don't have anything personally against Google, Cloudflare, or other big companies that has the Quad A, Quad 1, Quad 9, the resolvers. There's nothing personal in that. But I think we should offer an alternative for the people that don't want to use it. But the browser guys are sort of, especially Mozilla, is pushing for this to happen. So I think that it's important that the open source DNS vendors also provide alternatives. So you can run your own DNS over HTTPS server locally, and you have control over your DNS, because that's what it is about, to have a control. I know that, again, the claim is that it's improved privacy of the users, but it also prevents controlling the DNS traffic, and it's important in some scenarios. You want to prevent malware, maybe you have children at home and you want to apply filters, so what they can see and what they shouldn't see, or what they shouldn't post on the internet. So, keeping the control of your own network is important in some cases. One of the way how we could do that, the most probable way is that we will write a proxy module for Apache and Nginx, and other support for a proxy protocol in Bind. So it will be universal thing that could be deployed with any of the DNS servers. The last part that I think needs improvement, as I already told you, the Bind was the first to implement DNSSEC, and we gained a lot of experience since then. So I think there's a presentation on ISC website called DNSSEC in 6 minutes, and I strongly believe that the 6 minutes are too much. I think that DNSSEC should be enabled by simple, yes, sign this, and make this magic happen with your registrar. So it will pick reasonable defaults for the keys. It will try to automate everything: key creation, key rotation, child-to-parent communication using the CDS, CDNS key records, if the registry supports that, the periodic signing. So all you would have to do is to say, yes, I want this DNSSEC. I don't know what it is, but it seems nice, so please Bind, do it for me. And also improvement in some more niche areas like offline cascades, maybe stored in HSMs, or combined signing keys to reduce the answers, so you have just one key. And that's possible because the rotation will be easy with the CDNS key, CDS protocol. The next thing this is not about the code, but it's about, I think that the conversion did something to the table here. Or maybe when I stretch the slides. Again, this is a timetable on the top. This is the release schedule I talk about. So we do have a stable releases, that would be 9.14. We have a development releases, that's the odd numbers. And and then there are extended support versions. So every 2 years, we will release the extended support version that we will keep supporting for at least 4 years. The next one would be 9.16. We are changing the schedule, so it's a little bit different than it will be in the future. So 9.16 would be extended support version, 9.12 will be an extended support version, and 9.16 will be released next year, 2020. What we are also changing from 9.14 and 9.15, that we would like to do time-based releases. So the current plan is to that it will be the third Wednesday in a month. So the third Wednesday on the month, there will be at most release. So if there's not enough, stuff in between, we will probably not do the release, but we will not do them outside of this window. So if you are maintaining your network, you will know, hey, it's a time that there might be a new bind release that I want to upgrade because there might be a security update. So this means it will be more predictable, and it will be easier to work it into your plans. How do you manage your network? So that's all from me. And now I'm ready to take questions if you have any.
Any questions for Ondřej? Sorry, can you wait for the mic? And thanks.
Hi, Anders living here, Abundo. Do you have any plans for adding any SQL support, for example, as backing store?
There are right now there are 3 different ways how to add more stuff into Bind, and that DLZ, that's the old interface. And there's a new one written by Red Hat DynDB, which you can use to write a new database support if you want to the zone stored differently. And I expect that in a time they will converge into one plugin interface, so you will be able to add a new module that will handle the configuration. They will handle the database. They will handle the zones. They will handle the cache. So this is really long-term plan for Bind. But since we have the plugin interface now, we want to chop off the pieces of Bind into separate modules that will be still maintained by us. But so the core of the Bind stays really slim and thin, and it could be easily refactored. But it will also allow people to contribute more modules that will do some stuff they need. And did that answer your question?
Thank you.
Another question for Ondřej. Okay. Well, please join me in thanking Ondřej for his presentation. Thank you.
Thank you.
So the second speaker of today's session is Torbjörn Raum from Adva Optical Networks. He is the sales manager in the Nordic and Baltic regions, and he's been involved in telecom business for many years, with the last 12 years working for Adva in various roles. So please, could you join me in welcoming Torbjörn to the stage?
Oh, very good mic. So, as you heard, my name is Torbjörn Raum. I'm very pleased to be here today to be able to present you why higher application layers should actually know about software-defined optics. So I'm inheriting this presentation from Stephan, who is a business development director and have huge amount of experience in this area. So I will do my best to interpret his thinking and the messages he wanted to give to you today. And I hope this will be sufficient for you to understand where we are today and what we are going towards. So I was thinking a little bit about how to present this to you. Everybody remembers a story. So how do I start this story? Once upon a time is a fairy tale, right? And this is no fairy tale any longer. Maybe a few years ago we could have started. Once upon a time we had, oh. But today, this is getting close to reality. So I wanted to start this story by giving you a picture. What am I talking about? What are the stuff that you call big fat pipes? What's the components behind these big fat pipes? And how can we utilize dynamics in this environment to give you and your end customers better service? Right. So this is a picture I found on Netnod's homepage. I'm not really sure what this service is. If I can find a pointer. These are the big fat pipes I'm talking about. In your schemas or your applications, when you're trying to picture what is, we have two endpoints needing communication, and they usually are just a white line. What is actually behind these white lines? That's what we're going to talk to about today. So, to do this, I will try to cover this in 2 steps. First, we will talk about the advances in technology that enables us to have to enable this dynamics in the optical layer, which previously has not been so easily achievable. And then secondly, we need to tie this up into some kind of bag. How do we use this then for our benefits? Okay. So first, advances in optical communications. So this is a traditional optical layer. What has, we can see on the right-hand side, we can see a sort of a network of nodes, very well defined. We have endpoints, we have a meshed network. Communication could be between any of these points to any of the other points. However, we have been using a very strict optical spectrum. Each channel has been 50 gigahertz, 100 gigahertz, or whatever gigahertz. And it's split evenly over the spectrum to give us 40, 16, 80, a number of channels. But that's it. It has been fixed like this. On the optical layer, we have had limited reconfiguration possibilities. It has always been meant that you had to send somebody out there to really do some reconfiguration, the plumbing. we had to send somebody out there. The system itself was sort of stupid and only did what we told it to do. The interfaces on the end sides here, they have been using fixed data rates, not enabled to really be changed on the run. They're using fixed modulation. Oh, sorry. I'm not done yet. Fixed modulation schemes and fixed the FEC, the code that actually corrects potential bit errors going through the network. So what all of this stuff has resulted in is that we have a permanent connection. Once we have identified a need going to communicate between site A and site B, we have sat down with some planners do the manual configuration of all the components needed for this, and set up the service, and it will remain the same until you say, we don't need this anymore, and you free up the resources. But this will change going forward. So to give you some background, what happens when you have a bunch of data coming from the router on the right-hand side? It enters a terminal component that translates the gray data bits to something colored and being able to be transported over the DWM layer. What happens then after it leaves the transponder unit in this side? This terminal could actually be integrated into the router as well. Yes, so it leaves the terminal. It's very well defined. You can see that it's sharp and crisp, and it's very easily to decide if it's a 1 or 0. And once it goes over the optical layer, sometimes you will go extensive distances, and the signal will be attenuated. It will be muffled by the glass. It's not perfect, so over time the power of the optical signal will degrade, and you will need to amplify it. So depending on how long the stretch between the endpoints are, you will need to amplify it 1 or 2 or many times. And for each step, as these components are not perfect either, the signal will be muffled. It will be mixed up with stuff we don't want, noise. And this is depicted by, as you can see, the signal is very crisp in the beginning, but after it passes each amplifier step, it gets more fuzzy, less possible to detect. And the trick is, of course, to reach this endpoint with enough clarity of the signal to be able to detect if it's a 1 or 0 in the end. Sorry, I will just get some water. Okay, now I'm ready again. So in the end, so the signal degrades, it will be more noisy in the end. In addition, we can encode more bits into each symbol we transport. So as you can see, we can use higher order of modulation schemes, which enables us to send more data per symbol, which in the end translates to higher bit rate per lambda. But of course, you can see, depending on which modulation schemes we're using, its complexity grows. And if you then combine the modulation scheme and the complexity of it together with the OSNR, you can see that it's a trade-off. Higher modulation scheme, higher bit rate, lower distance, right? You can't use as many amplifiers because the noise will be, in this situation, will be more significant than if you use a simpler modulation scheme. Okay. Then, this could seem a little bit complicated, but bear with me, I will try to guide you through it. These enhancement of the optical signal, which traditionally was just Morse code, like on-off, light on, light off, has now come to a place or a more advanced state, which we call coherent. It means that we're not just using the light on, light off to detect what kind of data we're transporting. We're using more advanced detection methods. And in that, okay. So then we can delve down. What does this coherent modulation options give us? Well, in the end, as I said, it's a trade-off. It will be a trade-off. But it will enable us to give us the best possible transmission characteristics that we give the resources for, or make the resources available to. Of course, it will enable us, if we such want, I mean, in the end, it will be a lower cost per bit, as we can use a decisive number of resources in the optical layer to enable this transport. Or if we have a really high need for high capacity, then of course we could use more resources in the network and enable us to give us a better density of the transmission, but maybe not so much reach and the reach. And then, of course, in the prolongation of that, it will be a higher cost to implement the service, but that is a cost we could live with as we need the higher capacity. So if you look at this one, we stick to this 200 gig per channel. You can see that depending on which modulation scheme we're using, if you're using QPSK, 8 QAM or 16 QAM, we will encode different amount of bits per symbol. But the trade-off here, you can see that we are able to achieve 200 gigabit per wavelength. But depending on which modulation scheme we use, we will use different amounts of the spectrum. And then if you have a need for 300 gigabit, you can see that we will need to use another set of modulation schemes, but we can, in a similar way, tweak the signal to our needs. Do we need to save spectrum to squeeze in as much channels as possible in the spectrum with long reach? We need to use a higher modulation scheme, but then the reach, of course, will go down. If you use a more spectrum per service, then we will have a longer reach of our system. We could turn this around. And now we have on the x-axis the nominal bit rate, and on the y-axis we have the reach. So in a similar manner, we can then see we have different modulation schemes. The QPSK is not fitting into this picture. It's above here. But to keep this nice and neat, we concentrate on the 4 higher ones. So then in this picture, we can then look at, okay, we have a 16 QAM 200 gig wavelength. This could actually, with the same modulation scheme, be upgraded to 300 gigabit per second at the cost of, in this end you can see a narrow channel, and this one is a wider channel. So you can then deciding how depending on how much bandwidth you have per channel or allowing the channel to use, you can come up to even 400 gigabit, but using then 75 gigahertz of spectrum. Or you can achieve 200 gigabit, but only using 37.5 gigahertz. So, why is this then important? These achievements that we have reached. Of course, in addition to the transponders that I'm talking about, the endpoints talking to the optical layer itself, of course, needs to be upgraded. I will not cover exactly how this is done, but of course they will need to go hand in hand and be also upgraded and being able to handle these variations of the optical signals, the optical carriers going through the network. So here we can see an example. We have a router, I'm trying to point. A router in Gothenburg and a router in Stockholm. We have optical layer in between. We have originally planned a 300 gigabit service going through this. And we have enabled optical restoration in this optical layer. We have told it, well, these are the nodes you have available, the whole thing. We need to get a service from Stockholm to Gothenburg with the X number of gigabit. And you're allowed to use other resources if something happens to the network. And in this case, somebody digs the fiber off. So then the optical layer itself will, okay, something has happened. It detects something has happened. It reacts and it says, okay, I can reach Stockholm, but we'll need to go through Malmö. And in this case, of course, the distance that this signal has to travel is a lot longer. Not going directly to Stockholm, but it has to go down to Malmö and then up again. So the restored path with the given resources are only allowing 200 gigabit. So the system, of course, can react and give the routers 200 gigabit. However, when we start to look at this type of events and flows and dynamics in the optical layer and transponders and its components, of course, this is not optimal. I mean, we have a service here that is thinking, I'm going to get 300 gigabit, no matter what. So this requires communication. Christian Larsen talked about communication yesterday. I thought it was interesting because it touches this a little bit. Of course, it's not any code and stuff like that. I cannot go into that detail, but it's all about communication. The optical layer, it feels happy. It has restored the service to the extent what it's allowed, given the resources it has, and says, wow, I'm done. The routers are semi-happy. They have a service up, but not what it expects. And of course, above this, we have some functions or some customer wanting their applications to run, and maybe they have written their applications to depend on the 300 gigabit, but it doesn't really understand why it doesn't get it. So communication will be needed, and I will come to that in the second part. So, wrap up the technology. I'm getting a little bit short of time. This is what we have traditionally had, very rigid, not dynamic optical layers. Given all the technology advances, we are getting there. We have transponders and the optical layer that can react on unforeseen events like rerouting, and given that we give them the rules and limitations between what it's allowed to do, it can react on its own. So how do we then use this in a wider sense? Yes, of course, we will need to have some kind of management system on top. This is normally depicted by this. So this is a very generic picture depicting a hierarchical multi-domain SDN architecture. So SDN is a very hyped word, but it's a software-defined network. So in this case, we have, on top, we have a requirement. I need a 100 gigabit service between A and B. It should be encrypted, it should be whatever you can think. Below this, as this system doesn't know how the transponders from vendor A is working, the optical layer from vendor B is working, or how the door alarm handles in domain C is working. So I don't know how that should be relevant, but this depicts different parts of the network that could be relevant for the service. And to be able to not have all the intelligence in one system, so traditionally in an optical layer, we said that everything needs to be delivered by vendor B from starting point to end point. But in this type of new network, we're dividing up the resources so that you will be able to select transponders from one vendor, optical layer from another vendor, and cherry pick the configuration that you require. The network elements in domain B will report, these are the resources I have. The domain controller for these network elements will communicate with the SDN controller or orchestrator, depicting or informing the orchestrator, these are the resources you have to use, that are available for your use to create whatever your master is deciding that you should create. So this is normally what I wanted to wrap up. So this is the traditional telecom network, building an optical layer with a network management system reporting to some NOC or whatever the problems it has, but it doesn't really allow the top levels to do anything with the network elements. In this scenario, this network management will say, these are the resources you have available. These are the resources you can use to create whatever these guys want. So this could be a fairy tale, but we are closer to the reality than you can think. In the OFC 2019, we had a demonstration of this using entity communication and Telefonica operator OSS BSS, which was telling the open source ONOS orchestration software that it needed to create a service from here, down here. In this case, the Nokia transponders doesn't seem that they have their own NMS, but they are configured directly from the orchestration layer. But in the case of the optical OLS vendor, we had our own controller in between. So down here we can see the network elements, and these are network elements, of course, for the transponders. These communicate with the OLS controller, stating these are the resources you have available, and the OLS controller then talks to the orchestrator with Transport API. So it delivers understandable language and predefined how to communicate and send requests to the optical layer. And in the same manner, the transponders are using a different protocol directly talking to the orchestration software, the ONOS. So, this is reality. This is coming. The stuff is there. Of course, there are different interests, different powers in the industry that says our way is the best way. So this ONOS is just one solution. There are many different ones out there. I use this slide just to show you that this is one possibility. Of course, you should investigate the other ones. What then are we going to achieve? What is the benefits of having an intelligent network able to resource its own problems, do the self-restoration, tweaking the services? What is the benefits? What are our benefits? Well, it's really up to us, right? We need to decide, how are we going to use these resources? How much intelligence, how much enforcement are we going to give? How much should we let the optical layer itself do its restoration and trying to achieve what we have told it to do? In the end of the day, we can use all this to tweak the communication paths in our networks, to be able to deliver bandwidth as a service, optical spectrum as a service. And in the end of the day, this will save dollars and cents for you. Thank you.
Time for one or two quick questions. Anyone has any questions for Torbjörn? Okay, please join me in thanking Torbjörn for his presentation. Thank you.
Thank you.
So the final speaker of today's session will be Henrik Börjesson from the Telia company. Thanks. Henrik is a Microsoft certified engineer with many years of communications experience. Please welcome him to the stage.
Thank you. Thank you to Netnod and Surý and all other people who have done a lot of effort to have this meeting available. You have been sitting for a quite long time now. Please stand up and give each other a high five so that you get some blood in your muscles before I take you on a small journey. I work for a company that started 1853, not 1953, as the Kungliga Telegrafverket. Today, 166 years later, we are still coming with new things. 1877, Kungliga Telegrafverket made an investigation if the new phones that came from the United States should be used. No, they have a purpose. We can call the closest neighbors when they have received a telegram. So that is a good thing, but we won't use them in Sweden because the distance to be used was only 50 kilometers for the microphone in the first phones that came. Well, Telia has changed their mind, was needed to change their mind that time, and they've changed their mind later on also. Today, new services are coming, and Telia has an agreement with Microsoft that we love Microsoft. We are partners in gold and silver partner in several areas of Microsoft's portfolio and services. And the new thing that is coming from Telia this year, already in June we expect, that is Teams telephony. How many in here uses Skype for Business today? How many uses Teams? Yeah, more than half of the people here uses Skype, and not so many uses Teams. Teams is available as a service from data centers in 53 different regions all over the world. In Europe, we have 12 different data centers, and Microsoft has bought 260 soccer fields outside Gävle-Sandviken. So something is happening in Sweden also, if you work for a company that needs to keep your data inside Sweden. The services that are provided will be connected by you guys. So we really need you, and we need good optical fibers. The changes that is coming also is that we will see more real-time traffic, and it will be used in many different networks. Telia has also been selling express routes since 2013, which gives you a more direct connection, direct to Microsoft data center for your company. Telia Carrier, that is part of the Telia company, AS1299, is a Tier 1 provider, which has access in 115 countries and cooperate with other Tier 1 providers so that we can give access in at least 205 countries all over the world. I am not sure how we can fix it in North Korea yet, but somebody's thinking about that also. We are one of the largest provider in Europe of giving traffic over to all continents. And we have pop-ups in 280 cities all over the world. Here you can see a small picture of the pop-ups in Sweden, in Europe, and to United States. There are pops or pop-outs, breakout points. Thank you, Jörgen, for correcting me here. But I was going to speak about Microsoft Teams here. Here is the interface of Microsoft Teams. It has the capacities that you use in a team, both with chat, with its needs for communication, and it also gives you the ability to complete meetings, book and schedule meetings in your calendar, and easily communicate with each other in the team. The difference between Skype for Business Online and Teams is also the ability to handle files and other web services that is coming. You may use other web services. How many uses Dropbox inside here? A few? Yes. That one can be used in a specific channel in Microsoft Teams. If you have connection with your travel companies to book your travel here to Netnod Meeting, you have a web service for booking your travel. That can be available for all the Teams users. And you can also create own applications or bots that helping you. We are not so deep as Åsa spoke about yesterday about advanced of AI, but we have here now that we can take away repeated tasks and remove them and replace them with web services instead. When it comes to collaboration, yes, if you only remember one thing and using Teams today, remember hashtag and remember @ and the word Teams. All the people in your team will be reached by the message you're sending out or the meeting you're calling into by that command. On the top, you see search or press control or / in the Teams client. Here you can also just using the @ sign or / and typing DND for do not disturb. And immediately your presence is changing from green available to do not disturb because you are in a presenter modus. All the files you are working on together can be stored centrally with given access to each individual team members. So you don't need to send out and having the latest Excel sheet copy of somebody who edited the files last time. They are available, and you can set retention policy of how many copies you should keep in the solution. It is simply an effective tools for working together, updating projects, files. You can also use it for giving access to external people in your teams that you are dependent of an important supplier or a customer project. They can be part of your team if you're working with. Teams is available for all modern available devices like Mac, PC, iPads, Android plates, all major phone attributes have applications for this one. So the extended network needs to be working everywhere with security. And it is available with multi-factor authentication also, so that you can have confidence in who is reaching your data. You need a new web service. Well, Apple showed us 2007 what's happened with App Store. Microsoft came a little bit later on, and they have now their own store where you can buy different bots with web functions that you integrate to your teams. You apply the bot that you need, and it will be used for the web services you set up, so that you can take control in your company and using those web services that you are planning to. If you go and look in the admin center, it is easy to apply the Teams license that you need from Microsoft. It is the same admin center for Skype for Business Online and Teams. But you apply different policies for users, and they will be part of your team. The architecture of Microsoft Teams is a combination of different things. On top, you see the Teams client that is used in your desktop or in your mobile or plate. That uses Microsoft core services for meetings. It uses the Exchange calendar for invitations. Your external partner, they just need an email address to be able to read the link that you send out if you schedule a meeting, and a good headset that is connected. The intelligent communications or in the cloud, that is based on OneDrive and SharePoint Online. Those services are already included in the E1 license that you can buy from Microsoft. The Teams services combines Skype for Business Online in the bottom, and you can also add extra SQL services, Power BIs, connectors to your information system regarding customer or Salesforce or what other customer relationship management program. Microsoft is focusing on, they have been offering Lync or Skype since 2007. Before that, they had a tool called Live Communication Server. But now we see a development where we get more function. Before, the on-prem solution has had more functions than the cloud solution. With Lync and Skype, they were close to equal, not really. You had better control of the network traffic when you had Skype for Business on-prem instead of the online solutions. But the next step, you will have more functions in the cloud solution from Microsoft here. And that is a changing theme. Microsoft is still developing Skype for Business on-prem, and the newest version is called Skype for Business 2019. That is available on-prem, and the same functionality is available in the online solution. But how should this cooperate with Microsoft Teams? Well, there is a journey that you make, and the journey is that you decide how should we cooperate, and you apply a policy to different users. The best way to confuse your coworkers is to set up the Skype and Teams in island mode. The island mode gives your users 2 buttons in Outlook, one for Teams meeting and one for Skype meetings. Which one should they use? Well, nobody tells them, and they have to find out themselves. Instead, if you decide another mode, not the island mode, because those are distinct, separate parallel channels, which gives confusion. Instead, you can start with the IT department, give them a parallel working environment. The other ones start with, for example, only collaboration in team and keeping Skype for chat and meetings. When you come a little bit further down the way, people are getting used to the Teams interface. You take another step, and you involve more people in moving them from chat in Skype to chat in Teams and meetings in Teams. That you can decide, and you can give information. And Microsoft's goal for this one is that you move your communication and chat and meetings over to Teams meetings, which has more improvements than what Skype for Business Online have today. Here is a picture of how Telia has solved the solution for our customers that also want to use Microsoft Teams as their phone system or PBX system, where we have a combination of both mobile network and the landline networks. We open a zip trunk over internet, sends encrypted information with TLS encryption to Microsoft Office 365, but we keep the voice traffic if the user is in Sweden today. Then the traffic will stay in Sweden. The signaling will go to Teams, and it will also do a parallel ringing to your mobile when you do a call to your fixed line number. Microsoft has set up a standard for this and approved some of the largest media gateway companies. The 2 that are approved today, that is Sonos, or Ribbons as they're called now, and AudioCodes from Israel. They send encrypted traffic over internet in the setup. To program an SBC, that is not for the normal people, but it is available if you are skilled into communication. Telia have 2 offers, one where you rent the SBC from Telia, and the other one where we do a customized project if you want to use your PBX for some functions and Teams telephony for some pilot users. Then they can be combined, or we can set up parallel ringing also. Here you see a typical picture of what you need to meet in a solution today. The communication goes from the telco, the phone connectors. You arrange either parallel ringing to your mobile phone. You have good conferencing phone systems that may use an analog line, or you want to answer on your fixed phone or in your Skype or Teams client. There is also an attendant console for those people who are working in the reception and you're calling a functions, please can you connect me to the sales department or the support department? Well, then you need somebody to find out, well, this guy has left the building and he will be available next week or in the afternoon. That is the attendant solution. Microsoft has one. Telia offers an extra flavor to that one also. I will show you this one a little bit later here also. How many here uses quality of service in your networks today? A few guys, yes. How many thinks that the sound quality in the phone systems are bad today? Yeah, a few guys. Quality of service can help you to improve the solution today in your already existing infrastructure and give you real-time communication, better quality. Usually we prioritize voice to come quite high in the classification of the services. But in this solution here, see if I can. Well, we can have quality of service in the media traffic from the telco SPC over to the different users. But when we send the traffic over internet, over the mobile network, the quality of service disappears. Quality of service, for those who are unknown to it, that is to give an extra prioritization for voice traffic and letting email and file download to take a few seconds longer time instead when you need more traffic for that one. The attendant solution, that is something that we see around the corner. Microsoft has it on their roadmap and it will arrive under 2019. There are also already coming phones that are certified for Microsoft Teams, and they have also made a firmware upgrade if your company has bought phones that was used for Skype for Business online. Those who are being part of Skype projects earlier also know that there is an older phone system that is called LPE that won't be able to be supported for Teams. That technology is too old in those older models. Poly, that was earlier called Polycom, they have also phones that are coming now 2019 for Microsoft Teams. Here are the 3 different alternatives that Telia offers today in Skype for Business. How you can combine phone system and integration with your mobile phone with an attendant solution. Here we have 3 different flavors with different prices and different functionalities. I have another one with more than 80 different functions that is different in those solutions, but I think you are too hungry to listen for me about that one. So, when we come to Microsoft Teams, the first alternative we won't give you a solution for, because Telia Office 365 requires encrypted communications. So there is why you need a service session border controller, which transforms your unencrypted voice traffic over to TLS encrypted traffic. That SPC you can buy as a service with standardized functions, or you can set up a combined SPC that is working together with your already existing phone systems. If you want to learn more, there are already more than 34 user videos about Microsoft Teams available from Microsoft. And there is also for you IT pros, there is live training and IT professional at Microsoft Academy. You can get the training course how to do the different setups for Microsoft Teams and functions. Teams telephony. Here I was supposed to have a live call and showing that we were not just joking. Anyone who knows one of the earliest jokes that came from Telia? In 2003, you can send an SMS to stop space joke on an SMS. That stopped you from receiving jokes from over SMS, Telia announced. But here is reality today that we have provided to some customers. The dial pad is available when you activate phone functions in Microsoft Teams. Here you can add your colleagues, those you often communicate with, and you can make calls. When somebody is calling you, you see they show up as a toaster down in the right corner. You can decide where you want to have that toaster being placed on your screen also. The calling function is integrated in Apple Call Kit. So in the you see the call coming up. It will, if you don't answer, it will be placed in those missed call lists as you have for all other calls. So that there you have a good integration. Android is working on it, but you don't see a missed call from Teams in the standard phone list on an Android phone. But you see then in missed calls of in the Teams client that is available for Android. If you want to see a live demo, my colleague Daniel down here, he has equipment, so we can show you live here. But there was problem to connect this and have the live demo here from stage here. But we are here. We are here today so that we can, if you are interested, we can have a small session here later on. And the signal comes up. You can select if you want to show your fixed line number or your 070 or your mobile number when you're dialing out. You can also have a policy for people working in customer service that you show the customer service number or the main number for the company when you dial out if you're working in a function-oriented solution. Questions so far? I may have talked too fast, I know that, but...
Do we have any questions for Henrik? Okay. Well, please join me in thanking Henrik for his presentation. Thank you.
Thank you.
So, ladies and gentlemen, that brings us to the end of the Netnod meeting. Don't worry, lunch is ready for you outside. There will be a course starting at 12:15 for those that are attending Patrick Jones' DNS course from ICANN. But it only remains for me to thank, first of all of the Netnod staff that have worked so hard to make this meeting happen. Thank you very much to them. Thank you for attending and for the people following on the live stream. And finally, thank you to the sponsors, Adver Optical Networking, Conapto, and Interaction. We hope you've had a good meeting, and we look forward to seeing you again. Thank you very much.